So in this second video of RAC, we will be dealing with heat engine and heat pump. Let's directly dive into what is heat engine and what is heat pump.
So basically heat pump and heat engine both are devices. Now let's look and dive further into what exactly is heat pump and heat engine. Now basically heat pump is a device. It transfers heat. From low temperature to high temperature. Okay. Now since it is a negative temperature gradient, transferring heat from low temperature to high temperature is going to require some sort of external work. Okay. So, low temperature to high temperature means that transferring heat from 20 degrees Celsius to 45 degrees Celsius. Okay. So basically it comes with a flow diagram, and for that we need a heat source. After heat source comes the heat pump, and after heat pump comes the heat sink. So let's make good blocks for this. Now, when the heat is added from the heat source to the heat pump, we denote it as QA. And when from the heat pump, the heat is rejected to heat sink, we denote it by QR. Also, this external work is provided by us. Therefore, the arrow is inside that we are providing the work, that is W. Now, we all know that COP is equals to output upon input, right? So here COP comes for heat pump as output is amount of heat rejected, because our sole purpose is to transfer heat from low temperature to high temperature. So that is amount of heat rejected to input. What is the input? The net work which we have provided here. So we'll call it as net work done. And thus the COP becomes QR upon QR minus QA. Okay. Now since it is from lower temperature to high temperature, we'll consider source as T1 and heat sink as T2. And therefore, at any time, T1 is always less than T2. That is the whole and sole purpose of using a heat pump. Similarly, you can write this COP in terms of temperature. For QR, we'll write T2. And for QA, we will write T1. And write the equation same as that. And we'll write the equation same as this. Now next, heat engine. Heat engine is also a device. It converts heat energy to some form of useful work. Now, again, we need a source in the flow diagram. After the source comes the heat engine. And after the heat engine comes sink. Now, since heat energy is being converted into some or the other form of useful work, we are going to get work as the output. And that is going to be QA minus QR. Again, here heat engine absorbs some amount of heat and rejects some amount of heat. Now, the heat energy added to the system is not converted into useful work completely, but some amount of it is rejected to atmosphere, or we can call it as a sink. Now, thus, for heat engine, we have the efficiency as again output upon input. Here we get output as work done, and input is the heat added to the system. And thus the equation becomes as QA minus QR upon QA. Now separating the denominators, we get 1 minus QR upon QA. So one point to note about the heat engine is that efficiency of heat engine is always less than 1. So this is all about heat pump and heat engine. Hope this helps. See you in the next video. Thank you.